Okay, 10:52, Grumpy Bookstore owner. Today, the bookstore owner has a store open for customers that length minutes. Every minute, some numbers of customers stop by, enter the store, and all those customer leaves after that end of that minute. On some minutes, the bookstore owner is grumpy. If the bookstore owner is grumpy on the I minute, grumpy supply is equal to 1, otherwise, grumpy supply is equal to 0. When the bookstore owner is grumpy, the customers of that minute are not satisfied, otherwise, they are satisfied. The bookstore owner knows a secret technique to keep themselves not grumpy for X minutes straight, but can only use it once. Return the maximum number of customers that could be satisfied throughout the day. Okay, cool. Um, do we have? Is just satisfied? There's no like delta thing. Okay. Which is roughly the same probably, but okay. So I've gone before these moments. Customer this. Okay. Um. Hmm. There are a couple of ways I could think about this problem. I mean, the first one that I'm thinking about is kind of it seems like it feels like a very rolling window type thing, which is you have a window and then you kind of move it along, and for X minutes it's kind of right. Um, so so I guess the naive algorithm is probably something like I don't know. Well, the really naive algorithm is probably n squared, but probably should not do that, or n times x or something like that. But which is I guess n squared looking at these constraints, but that's going to be too slow for 20,000. Um, but yeah, I mean, it's just to bring it up. I wasn't seriously considering that. I think the rolling window is probably somewhere to go. But yeah. Oh, see y'all later, Drewzon. Juicy out, Eon. Yeah, yeah. Catch it on YouTube's. Uh, hmm. Okay. Uh, well, we have the base number of satisfied customers, so then it becomes if we flip x consecutive ones, then you get that delta. Uh, yeah, I mean, I think the rolling window is the way to go, but I think some of it's just maybe there's some edge cases I want to make sure I get it, but I think this should be okay. Uh, okay, cool. Uh, Yeah, I mean, I think so. Yeah, if you look at it as a rolling window, you have an array, and then you just start with the first X minutes you use this superpower for, or whatever it's called, and then you change it to starting on the first minute. So then you do some operation on the civil index, and then you add in the new index and so forth. There's some magic, something like that. I'm hand waving it over. Please stop me. But otherwise, I think I could code something up and then kind of see how it plays around. I think the rolling window is the way to go, and the um, and in that case, you're probably going through the way 2 or 3 times or something like that, like a double pass. So that should be off, and that should be okay. I wonder if this helps. Hmm. The fact that each one is less than 1,000, but I think that's just maybe to keep things under, so that it doesn't overflow for whatever reason. But okay, yeah. Do I want to in C? Yeah, let's play around. Yeah, let's do C#. I haven't done anything in C# in a while. Uh, okay. So sum of happy people isn't reduced. Okay. I guess I could use for each in C#. I'm not great at link or whatever it's called. Yeah, link, LINK, Q. Because you can probably do that in one line, but definitely, but it's fine. Last time I used C# was C# like 4 or something, or 1.4, whatever version. So, yeah. Uh, okay. And then now we want the rolling delta of the first x. Okay. This one out. So even if we don't use the superpower, we get max compile. Because I'm used to using, I think one thing that I try to do, just because it simulates real world interview experience, kind of especially on the whiteboard, is not to use it. That's why I do everything in Leetcode web browser thing. But I'm very used to C# having IDE and autocomplete and stuff. So I have to double check and have to compile just to make sure that I have the right syntax. It's been a while, but yeah, that's right. Just add now for wait, no, that's not right. If grumpy is equal to, if you are grumpy, then we get this delta. Also, I did this, man, I think I missed a statement here. Whoops. So this is not grumpy, this is just the base sum. Okay. So now we kind of eject the x minus, or the I minus x element. Okay. I could put it inside actually, but that's fine. Okay. Now delta u minus, minus x is equal to, so if it was grumpy, then it's already in delta, but then now it's going to be grumpy again. Sorry. Oh. Yeah, that's fine. If you're grumpy now, then you're down to customer. Something like that. And then do another. It might be off by one. Let me double check this at some certain point. X. No, that should be okay. Well, no, it's okay, but it's not as long as before. Huh? Oh. Oh, so that's what I get for being fancy and using the for loop. Or for each loop. But this time I actually need the matching thing. Of course, if you have designed it well, then this would be an object. It should be okay. But well, like a wrap, a pairs wrapper or something like that. Anyway, well, that's hopefully that's a good start. But it is not correct. Do this? I don't remember the exact. Maybe I'm using Python syntax. So I'm print something. Yeah, okay. Excuse me. Okay, so x is equal to 3, that means we're adding this thing to it, so this is all of these. And these are hard to match up thing. Oh, maybe this is easier to see. Okay, so what is the right answer to this? The first three is 1, 2, 3, 10. Okay, so that's right. maybe this doesn't do the last roll off. The last 3 minutes. That sounds right. Outside of that, maybe I get a sign wrong, but yeah, we do this. This is at least 30, which is already higher than my thing. So, oh, this should be I minus X. That's probably what, oh, I don't know if that's why, but that definitely contributes. Okay, well, silly mistake. Oh, that's common. Okay, I've tested too much. Okay, let's. Okay, at least one customer. Okay, fine. And we know this is linear, so I'm not gonna stress test it too much. Okay, yeah, that's a little YOLO. Usually I test it a little bit more, but there's an edge case. There's an edge case. Okay, cool. Yeah, rolling window. Yeah, so I don't know if I explained this one well at all, to be honest. So feel free to ask me while I'm trying to explain it. But basically, what I did was I started with, well, you get all the non-grumpy customers. That means you're always going to get those points or whatever they call. That you're always going to get those customers. And then the answer is kind of having an overlap window of X minutes, and then kind of in a way flip those 1 to 0 so that you count them. And what I did was basically, and then you move that window side by side, and then like from left to right or so forth. I don't know which mirror this is, but and as you kind of move things from left to right, you add new people, or you add new customers that would have been grumpy, and make them not grumpy, and that, and and you leave on the other side where people who were not grumpy could become grumpy. So that's where these two statements are, and then you kind of keep track of the max along the way. So that's kind of how I would explain it. Though I think this is also, if I was in an interview, this is a problem that I would draw a whiteboard, and you have like you draw kind of indexes and then draw brackets and stuff like that to kind of explain it a little better. But without the help of that stuff, that's what I'm going to try a little bit. But again, feel free to ask. In terms of I think there's something better that maybe I'll try to explain. But I think in terms of kind of difficulty, this is on par with a lot of what's it called, like rolling window type problems. Maybe not, if not this per se, then something that resembles this. So I definitely recommend it. I mean, I think there are a couple of them. What is the canonical one that people always use? But yeah, so I would definitely practice this. I think there's some abstractions that I could make, but probably not by that much. I mean, at the end of the day, this is 3 for loops, and even then I could have probably made them into fewer loops though. I mean, obviously it doesn't actually change anything, but I mean, essentially it is a 2 pass because you start at this starts with 0 to X and then X to the N. So it's a 2 over N algorithm. I don't use any extra space, so this is all 1 extra space, or 1 extra space, which probably can't do better than reading in the data and getting an answer in constant space. So but yeah, it's nice, I guess. But yeah, and I don't think I optimize that much. Maybe I could be cuter about some stuff, but yeah. Sorry, I'm just reading Navi list comment. Now let me see. So Navi said, so you count the customers that are immediately without a superpower, then using the one window, you move on and keep track of new customers that will be happy. The answer to new happy do the superpower first. That's exactly right. And so you keep track of new customers that would be happy with the superpower, and also you, as you roll along, you also subtract people who were happy because of the superpower, but then they no longer are happy because they are no longer in the window, and that's kind of where this subtraction is from. And yeah, I mean, think that's very precise way of pointing it. So thank you for kind of summarizing it for me. Um, yeah, I think as an interviewer, I would. This is a cute problem. I think I would actually like. I like the difficulty of this problem. It's not too hard. For some definitions, too hard. I think there are a couple of things people can do as well, or, like with naive algorithm, and maybe even um, maybe not necessarily n squared, but like n times x, and then something. That's what I want to say, but because I think it's a little weird because I think the n times x algorithm is like very trivial to implement, and I don't know how much better. Like if I were to give hint to an interviewee, then like can he or she kind of use that hint to kind of make progress without giving out to like, hey, this is how you do it, right? And the implementation is not super interesting, but it's good enough. Like I mean, to determine whether the candidate is thinking about it. But I think some of it is kind of tricky in that I don't because I could imagine that you could write this solution in a way that has a lot more edge cases. Some of it I don't know if my like I might have a blind spot to how kind of complex people can make this code to be just because I have a lot of experience of doing this. So like I do things in a certain way because I've done things the long way before, but that was a long time ago. So I don't necessarily remember the long way of doing these. But yeah, I mean, I think it's okay. Cool. Explain the subtraction again. Not saying where customers can become unhappy. Okay. So it's not that people can become unhappy. It's that you're building off the problem. So you're actually basically given two problems, right? Let me actually. I mean, I don't have like a whiteboard, but I could try to do ASCII art a little bit. So bear with me. Give me a second. But basically, let's say x is 3, which I guess in this case x is. But so this is your kind of your first iteration of this loop. Looks something like this, right? So now you calculate, you know the sum of all these numbers where let me label this a little bit. Customers, grumpy. So you know the sum of all these numbers where the grumpy is 0, and then the delta, which is what I call delta, is just the sum of numbers that are where the grumpy is 1, right? So in this case, this would, well, actually, maybe it's a weird example, but so in this case, this delta would be 0 because the sum of all these components are whatever. And what we're calculating with the rolling window is that, so now we have the sum of, yeah. So now we just kind of move this along. Whoops. Move this to here. This actually doesn't. So now that your superpower moved along, now you want to add 2 to the answer because now you made a person that was previously unhappy happy, right? So okay so far. But and in this case, this person was already happy, or this one customer is already happy, so we don't make that unhappy. Right, so we keep the same amount here, but we added 2 more people. Okay, and then so that's kind of you do another max, see if it's good, so forth, and you move along to the next iteration. Then you move to another one, same thing, kind of. I'm gonna change this number so that's easier, so I don't have to. It's a weird thing, but let's say the answer was, you have some number, you have some delta and some here, some number of some SUM number of customers here with subset amount of them being happy or grumpy or whatever. So you move it along, right? So here, well, you add this, but this guy was, or this index is already happy, so you don't need to add anything. So like this never happens, right? But here, because we moved the window from here, oh man, the backspace is messing me up. Okay, but from here to here, that means we needed the delta is. I keep saying delta, but maybe I overload it. But you could imagine it going from this here to here. So the difference between kind of the two answers, if you will, is that well, you add the index 4. I can't draw a vertical highlights. So for this index, so you add this index because that's the difference, right? And then you subtract this, the index on the left, because that's also the difference between the two answers, right? So here, we previously added 5 extra people because of the superpower that they became from unhappy to happy. But now, now that your window has moved away, now you have to keep track of it, and then you have to subtract it back because now it's not affected by the superpower anymore. So the 5 now goes from being in the total, which was in well, in this case it's in delta. Now we have to subtract it out because that's just the difference. Hope that explained it kind of okay. Yeah, I mean, definitely if I was explaining on an interview, I have a whiteboard and I would draw this much faster, at least, if not cleaner. But yeah, so that's kind of how I thought about it. And there definitely, one thing I would urge is that for these kind of problems, definitely practice a lot. I think there is a lot of yeah, you could definitely do it in one pass. I mean, you could kind of combine everything. Also, hi Neil too. It's been a while. But yeah, I think practice a lot because I think as I was mentioning kind of before, these problems. I mean, I hopefully this doesn't come up as a humble brag or whatever. But like there are like when you have enough practice, you can make these things look a lot easier than like I make it look a little bit easier because it's like it's just 2, 3, 4 loops and they're like 2 if statements. But definitely if you're not as practiced, then like you think about all these edge cases, and for more complicated problems, there will be more edge cases with more if statements, and it could confuse you a little bit about which if statements you need or whatever, which logic statements. So definitely, it's something that I don't know. Watch, I say that now, and then like I'm gonna go to the next problem, and then I'm gonna jinx myself, and I'm gonna like struggle with like an off by one or something, which is something that I'm way mindful of. But yeah, you could definitely do this in in the same loop because you notice that none of the elements require knowing about the previous element except for here, which you could add if I minus x is greater than 0 or something like that. So you can actually move this up here, and you can move these 2 up here, and then so forth. So you can do it in one pass, but obviously in terms of the number of operations is the same. I like to prefer to think about it this way in general because I mean I know that in real world quote unquote, if you really want to optimize, it does take extra memory to set up like a for loop or something like that. Not memory. What's it called? Calculations, because you have to do like more array bound checking, even though it's not explicit here and stuff like that. But but you could very trivially turn this into one pass though. I guess is the point. But cool. But yeah, I think this is, speaking as an interviewer, I think this is probably way near the difficulty of a problem that you would see on a more difficult interview. So definitely, if that's what your goals are, definitely train for it.